In the 19th century, gold rushes changed the course of nations. In the 20th, oil reshaped the global economy. But in the 21st, or perhaps the 22nd, the greatest resource race of all may happen in space. Welcome back to Infinity Beyond. In this episode, we explore a future that's rapidly moving from fiction to fact: asteroid mining, and how it could create the first trillionaire, revolutionize global industries, and transform our relationship with the solar system. Let's start with the big idea. Asteroids are more than floating rocks. They are treasure chests orbiting the sun, filled with water, metals, and rare elements. Some are composed of nickel and iron, just like Earth's core. Others contain platinum group metals, which are essential for electronics, green energy, and high-tech manufacturing. In fact, a single small asteroid, just a few hundred meters wide, could hold more platinum than has ever been mined in human history. The monetary value? Trillions of dollars. But the real value of asteroid mining isn't just about making someone rich. It's about unlocking a new economy. Imagine this: no more scarring Earth with deep mining pits, no more dangerous extraction from politically unstable regions. Instead, we look up and harvest resources off-world. Asteroid mining could enable off-Earth construction, space-based solar energy systems, propellant production for long-distance missions, and eventually, self-sustaining space habitats. It's not just about bringing material back to Earth. It's about fueling the future of space itself. So how does it work? There are three primary types of asteroids targeted for mining. C-type, carbonaceous, contain water, carbon-based molecules, and volatile compounds. Ideal for extracting water for life support or fuel, split into hydrogen and oxygen. S-type, silicaceous, rich in nickel, iron, magnesium. Good for structural materials and industrial use. M-type, metallic, composed mostly of metallic iron, cobalt, and platinum group elements. These are the real jackpots for precious materials. The process typically follows these phases. Prospecting. Identify a target asteroid using telescopes and spectral analysis. Exploration. Send robotic probes to analyze surface composition, gravity, and structure. Extraction. Mine the surface or interior using drilling, laser melting, or even microwave heating. Processing. Refine materials in space or return them to Earth for use. Sounds futuristic? Maybe. But the first steps have already begun. Companies like Planetary Resources, Deep Space Industries, and Asteroid Mining Corporation have been seriously researching asteroid mining for over a decade. While none have yet succeeded in full-scale operations, the technology is catching up. NASA's OSIRIS-REx proved we can land on and sample asteroids. Japan's Hayabusa 2 demonstrated surface impact and sample return. SpaceX and Blue Origin are building the rockets that might carry equipment to these distant targets. Meanwhile, the European Space Agency, ESA, and NASA are investing in in-situ resource utilization, ISRU. The idea of using materials already present in space to build, fuel, and sustain missions. In other words, why bring everything from Earth when space has what we need? Let's talk numbers for a moment. Asteroid 16, Psyche, a metallic giant over 200 kilometers wide, is estimated to contain $10 quintillion worth of metals. That's more than the entire global economy. Of course, if we brought that much metal back to Earth, it would crash the markets. But that's not the point. The real opportunity is in creating a self-sustaining ecosystem in space, where resources are mined, refined, and used off-world without burdening Earth's environment. There are also legal and ethical challenges. Who owns an asteroid? Can private companies claim territory in space? The Outer Space Treaty of 1967 says no nation can claim celestial bodies, but it's vague about private enterprise. More recent legislation, like the U.S. Commercial Space Launch Competitiveness Act and Luxembourg's space mining laws, give companies the right to own what they extract, though not the asteroid itself. Still, this legal gray area could lead to space disputes, economic imbalance, or even conflict if not addressed proactively. That's why many experts are calling for a new international framework, a Space Resources Accord, to ensure responsible, peaceful development. But make no mistake, the first country or company that successfully mines an asteroid will change history. They will have access to materials that could build space elevators, power orbital factories, or launch interplanetary missions at a fraction of current costs. And they may become the world's first trillionaire. But more importantly, they will help humanity take its next evolutionary step, becoming a spacefaring civilization that doesn't just explore the cosmos, but thrives in it. Let's pause for a second and let that sink in. You're living in the generation that may witness the first asteroid mine, the first space-based refinery, the first blueprint for an interplanetary economy. One day, our descendants may ask, where did the space age truly begin? And the answer might not be Apollo or Mars. It might be a nameless rock, drifting silently through space, until someone saw not just a threat, but a future. In the next episode of Infinity Beyond, we bring it full circle. We revisit Earth and ask a pressing question. What happens when an asteroid actually does hit? From ancient impacts to modern simulations, we explore the science of impact events and what Earth's cratered history reveals about its future. If you've enjoyed this journey into the heart of asteroid mining, like, subscribe, and hit the bell, because the universe isn't waiting, and neither should we.